In this video, we are going to learn about the CPU. And the CPU can also be known as the central processing unit or the processor. And what we've been learning so far is that a computer is really made up of hardware and software. These are the two main things. One of the ways we could categorize a computer is that it's a combination of hardware and software. And we've also been looking at categorizing hardware by whether or not it's an IPOS device. So if it's an input device, that'd be keyboards or a mouse, that'd be an input device, or even this microphone, right? We could categorize hardware by whether or not it's an input device or an output device. So a monitor, speakers, those are going to be output devices, or a storage device, which would be like a hard disk drive, a solid state drive, a DVD drive. So we've started to see how we could categorize hardware into these four categories, IPOS. But what we haven't looked at yet is the processing area. We've looked at I, input, we've looked at O, output, we've looked at S, storage, and we're going to look at storage in more detail in a future week. But what we haven't started to look at yet is the processing category. So that's what we're looking at in this video. We're going to look at what a CPU is. And the first place I like to start is just by going to Google and searching for CPU and looking at the images, because this really brings up a visual representation of what CPUs are. And you have a lot of images here of different CPUs. And so this is the front side of CPU. There's often some branding on it. You can see Intel is a really popular brand when it comes to CPUs. And indeed, they are one of the main manufacturers of CPUs. And they were the company that invented the CPU. The 4004 was their first CPU, as I've mentioned before. And also up here you see AMD. So AMD, they don't have as quite a large of a presence. As a matter of fact, you don't see any AMD CPUs down here. You only see them up there. So if I was to search for that, oh, okay, now I have a few AMD CPUs. But they are another manufacturer of CPUs. And there are other companies out there too who manufacture CPUs. But just knowing that Intel is really sort of the industry leader when it comes to manufacturing CPUs, and they have just the consumer perception of being the best in the marketplace, generally speaking. They are the Mercedes or, I don't know, the Ferrari, whatever metaphor analogy you want to use, of CPUs. And then other manufacturers, AMDs, these are more like the Fords or the Chevys, a little less expensive. Still a vehicle, it's still going to work for you, but maybe not quite as nice nor quite as fast. That's just my personal take on it. Something else that's interesting is you notice a few system cases have shown up here when we've searched for CPU. And that's because people often incorrectly refer to the system unit or the case, this thing here, as the CPU. So if you ever hear somebody calling that the CPU, don't be confused. You know it's the system unit or the case. You don't need to correct them, but it's just a common misperception that people sometimes say that's the CPU. The CPU is located inside that, as is the motherboard. The motherboard is inside the system unit, and the CPU is plugged into the motherboard. But this is not the CPU. This is the system unit, the case, even though a lot of people refer to it as that. You also notice that the backside of CPU has pins on it. And these pins are where, when you plug the CPU into your motherboard, those are the pins that get plugged into sockets on your motherboard. And via these pins, electrical impulses can move in and out of the CPU. And so those electrical impulses represent zeros and ones. So a little impulse of electricity could be a 0 or a 1. And, that's how the CPU plugs into the motherboard, how electrical impulses get in and out of the CPU. So here you can see somebody plugging a CPU into the sockets, right? Each of those little holes would take a pin. And here's another image of somebody doing the same. That image doesn't want to stay up for whatever reason. Yeah, so interesting stuff just by searching for CPU at Google and looking at the images. Another thing you could search for, and what you'll see often if you look, what you'll see all the time if you look inside your computer, is if you go to Google and search for heat sink and look at those images, you start to see these heat sinks. And these heat sinks sit right on top of the CPU. So beneath this heat sink is the CPU. And what usually 99.99% of the time sits on top of the heat sink, all the time actually, unless somebody was dumb enough to take it off, what sits on top of the heat sink is the fan, right? And so what is happening here is that you've got your CPU plugged into the motherboard beneath the heat sink and the fan, and the CPU gets hot as it operates. And if that heat isn't removed, the CPU will actually stop working, and it could destroy or damage the CPU. So the heat sink is some sort of material which conducts heat, and the CPU gets hot, and then this metal sitting on top of it gets hot, and this fan blows air down through these openings in the heat sink, those little canyons, those slats, and that air gets hot, conducting the heat away from the metal. So the metal conducts the heat away from the CPU, and the air getting blown through the metal conducts the heat away from the metal. And that's how the heat sink works in conjunction with the fan to help keep the CPU cool. We saw that Intel and AMD are the main manufacturers of CPUs. The next thing to know about CPUs, the next terminology thing you should learn about, is that sometimes you'll hear about multiple cores when talking about CPUs. You'll hear about dual core or quad core, and just what the heck does that mean? Well, originally a CPU only had one core, right? And the core is the main components inside the CPU that do the processing. And so with dual core or quad core CPUs, what they've done is inside one CPU component, right? So inside this CPU right here, they've actually put 4 CPUs inside this one CPU, generally speaking, right? So I know it's a little bit confusing, like, wait, this is one CPU and it's got 4 CPUs in it? I'm confused, right? But the main processing components, the main core, which makes up a CPU, they put 4 of those into this one CPU. So really this CPU here acts like 4 CPUs. And when you start to get multiple CPUs, multiple processors in a computer, that is known as multi-core processor or multi-core processor, right? And a multi-core processor can sometimes also be referred to as multi-processing. So you'll sometimes hear multi-processing related to computers, and it just means somebody's using a CPU or that has multiple CPUs, multiple cores in it, or they're using multiple CPUs to do the processing that they're getting done. Generally speaking, you just need to know dual core, quad core, and that when you're buying that in the marketplace, the bigger this number, the more cores you have, the better. The next thing to know about is when learning about CPUs is you could go to Google once again and you could search for CPU diagram. And the CPU diagrams, and then go to images, right? Go to Google, search CPU diagram, and then go to images. And the CPU diagrams that come up, some of them just look a little bit intimidating. So that's kind of just interesting to look at. The main thing to know, however, for this class is a diagram that looks something like this. And this is a common diagram that you find in most introductory computer concept courses, which talk about some of the main components you find inside the CPU. And again, one of the things you'll notice is that there are these little lines there, these buses connecting these different components. So those little yellow lines represent the buses. And then a lot of these components, or some of these components we've already learned about, like the registers and cache. We already learned that these are places where computers remember zeros and ones. And so these are both memory areas, cache and registers, registry. And the registers are areas of memory that the CPU will use when working with zeros and ones. So it'll use the registers for working with zeros and ones. And cache is an area where it will store zeros and ones that are waiting to be worked with. And so it's kind of like a little waiting area in cache for zeros and ones, and that's where they'll be stored or remembered while they're waiting, and then they'll be used in just a moment. So they wait there in cache. We also have heard about I/O before. So this is the I/O unit, the input-output unit. This is where everything comes in and out of the CPU. And then we have the control unit, which controls everything that's going on inside the CPU, so very appropriately named. And finally, we have the ALU. And the ALU stands for the Arithmetic Logic Unit. And the name pretty much describes what it does. So the arithmetic logic unit, or the ALU, does the arithmetic inside the CPU. So it does the addition, subtraction, multiplication, division, all the mathematics that the CPU does. And the logic unit does all of the comparisons. So is this greater than, less than, or equal to? So it can compare two things. And that's what the ALU does. So this little diagram really describes the basic components which can be found inside the CPU, and that's the next good thing for you to know about when learning about CPUs. The next thing to know about CPUs is that the speed at which they work. So often when you shop for a computer, one of the main things you look for, one of the things you look for is RAM. So if I go to Start and click on, or right-click my computer and choose Properties, I can see that I have 16 gigabytes of RAM and that my computer is operating at 3.4 gigahertz. So this measure right here used to be megahertz, but now it's gigahertz. This measure right here is a measure of the computer's speed, how fast the speed is operating, right? So when we're buying a computer, we'll look to see how much RAM am I getting and how fast is my computer operating. And this one's operating at 3.4 gigahertz. Well, what is a gigahertz? What does that mean? And the computer has something called the clock rate. And the clock rate is how fast the CPU is operating. But the clock rate, the system clock is kind of like the conductor within the computer. And the conductor within the computer is kind of like the conductor from an orchestra, and he's setting the pace and the tempo by which everybody else in the orchestra is playing their instruments. And so the system clock sets the clock rate. And that's really the pace at which everything is happening inside the computer. Because if you look at this diagram here at visual6502.org and then you push play, you can see different pulses of electricity moving through this diagram of a CPU, this visualization animation of a CPU. And those electrical impulses need to sort of occur at a certain pace, right? So things are occurring within the orchestra, within the CPU, at the right pace, and everybody's moving and operating and doing things together, and they aren't clashing with each other and creating dissonance, right? It all has to occur at a certain pace. So that's what the system clock does. It sets the tempo at which the computer is operating. And the higher the capabilities, capacities of the computer, the faster it's going to be able to operate. And so the clock rate of this computer is 3.4 gigahertz. And that means that it does 3,400,000,000 cycles every second. 3,400,000,000 cycles every second. And what is happening with the cycles? One of the main things the CPU is doing is it's going through a machine cycle. And this is sometimes also known as the instruction cycle. Actually, that's the way it's most commonly known, but textbooks, for whatever reason, talk about it often as the machine cycle. So the instruction cycle or the machine cycle is a cycle that the CPU is going through. And what it's doing is it's fetching, decoding, executing, and storing zeros and ones. And so when a computer is going to run a program, it takes that program off of the hard disk drive and loads it into RAM. And the reason it loads it into RAM is because it takes too long to go all the way to the hard disk drive to get the zeros and ones and then to go back to the CPU to process them. And with that extra lag time, the extra time it would take to go to the hard disk drive, we would notice a real impact in performance, and we'd be frustrated because we'd be like, my computer's not operating fast enough. But if it loads everything into RAM, the CPU can access zeros and ones in RAM much more quickly. And you can see the RAM is located closer to the CPU, and its access is much more, you could access it much more quickly, but you don't get to store as much there as you would over in secondary storage, but you can still store quite a bit there, and the CPU has faster access to it. So the first thing the computer will do when running a program is load that program into RAM. And then from RAM, when the CPU or a program is being run, what the CPU does when it's going through its instruction cycle, machine cycle, is it'll fetch the zeros and ones from RAM. It'll maybe store extra zeros and ones into cache, like the next ones that are going to be coming, and then it decodes the zeros and ones. It executes the zeros and ones, so whatever is being asked of it. So if we were to do the addition problem, 2 plus 17, right? It would fetch the zeros and ones for 2. It would then store that 2 into the registers. It would fetch the operator plus. It would store that into the registers. It would fetch 17. It would look at that, right? It would decode it. It would execute that. It's going to store that into the registers. right? It would fetch the next instruction, which would be equal, add it all up, right? And it'd execute that, and then it would add 2 plus 17 and get 19, and it would store that in the registers. So fetch, decode, execute, store is this cycle that the CPU is always going through, and that's a little bit of how it works. Fetch, decode, execute, store, and from the time you turn your computer on to the time all electricity is pulled from it and it is off, the CPU is always going through that cycle. Fetch, decode, execute, and store. So one of the things you can visualize when you look at this right here is that that's just a series of fetch, decode, execute, and store. Another thing you can see here is that these little squares on the side, which represent the pins, are alternately lighting up and going off, and that's the electrical impulses coming in and out of the CPU. So just kind of interesting to look at. And one more thing that's interesting to know about this CPU, the 6502, this CPU came out in 1975. If you go to Wikipedia and look it up, and it was a CPU that was used in like the Apple II, the Commodore 64, the Nintendo original gaming system had it apparently, as did these other systems here. And the other thing that's interesting to know about is if we look at the clock speed, right? What's the clock speed of this CPU? How fast was it operating? And we see that the clock speed was 1 to 2 megahertz. 1 to 2 megahertz. And so now what we're looking at is 3.4 gigahertz, which is tremendously much more fast. So this is 1 to 2 million, 1 to 2 million cycles every second, 1 to 2 megahertz. And, now we've got 3.4 billion. So from 1 to 2 million cycles a second to 3.4 billion cycles a second. And so that's a pretty amazing thing when you think about how fast computers operate. It's doing 3.4 billion things, 3.4 billion cycles a second. So that's pretty phenomenal. So some basic CPU terminology here for you. You've learned some good stuff. You've learned the different names by which a CPU is called: CPU, central processing unit, processor, right? You've learned that sometimes people incorrectly refer to the system unit or the case as the CPU. You've learned what CPUs look like on the front side and on the back side, and that there are these pins on the back side where you plug the CPU into the motherboard. You've learned that Intel is one of the main manufacturers of CPUs and that they are the inventor of the CPU. And you've learned that AMD is also another manufacturer out there in the marketplace of CPUs, but Todd doesn't really like them as much as Intel, doesn't think they're quite as good, though they're still fine. They're still fine. They're like a Ford. Not quite as great as, I don't know, a BMW, but then you've also learned about heat sinks in the fan and how this is what you see when you look into your computer, and that the CPU is beneath that, and the role that the heat sink and the fan play. And then what else have you learned? You learned about dual core and quad core processors and what that means. And you've learned about the main components that you find inside a CPU, right? So you got the registers and the cache, which are different areas of memory, and the registers is the working area of memory, and cache is the storage area for things that are going to be worked with. And then you've learned that there are these buses, right, on the CPU where the zeros and ones, the electrical impulses travel. You've learned about the input-output unit. This is where the zeros and ones come in and out of the CPU. You've learned about the control unit. That's the unit that controls everything that's happening in the CPU. And you've learned about the ALU, which is the arithmetic logic unit, which does the math and the comparisons. And you've also learned about the instruction cycle or the machine cycle, which is the fetch, decode, execute, store, which is the holy grail of the CPU. It's what the CPU is doing all day long, all day long. And you've learned that CPUs do that incredibly quickly, that the clock rate, the clock speed of a CPU of a computer is really a measure of the computer's speed. And modern computers are operating in the gigahertz. And this one right here, you've learned that you can go to Start, right-click your computer, and choose Properties, and you can see what is the clock speed of the computer you're using. And 3.4 gigahertz translates to 3,400,000,000 things a second that the computer is doing, right? So it's going through the machine cycle, the instruction cycle, incredibly quickly. This computer can do 3.4 billion things, 3,400,000,000 things a second. So that clock rate is a measure of the computer speed, and it's set by the system clock. And that system clock is like the metronome, the conductor, which sets the tempo by which everything in the computer is happening. And it's not an arbitrary thing, like the computer can only go so fast. And sometimes you'll hear about overclocking. So some people will overclock their CPU. They'll go into their BIOS settings and set the clock speed higher than what their computer is rated for, and that could actually lead to a meltdown if you don't know what you're doing. I've never done it. I don't recommend it. But computers can only operate at a clock speed for which their hardware can handle, right? So it's kind of like, again, the car analogy. If you have a 76 Pinto, don't try to go 180 miles an hour in it. But if you have a brand new Lamborghini or Ferrari, right, and you're on a straight road out in the desert, you might be able to hit that speed, and your car is certainly going to be able to handle it. Whether or not it's safe or not, it's a different issue. The car will be fine; it'll be able to do it. So the hardware is built for different speeds, and the better we get at building hardware, the faster the speeds go. So you've learned some good stuff in this video.